thank you for coming to this event, which we've organised in collaboration with colleagues in the Research and Innovation Office at the University of Aberdeen. It's on the work being done on decommissioning the UK's offshore oil and gas platforms and redundant pipelines. So if you expected to come to something else, you've come to the wrong place. As you've no doubt heard from our speaker this morning, Professor Richard Neilson, who is the Centre Director, the ambition of the National Decommissioning Centre is to be the global leader in research and development on oil and gas decommissioning. I'm afraid we've just got a glitch on that, which comes to the housekeeping. I'll get to that in a minute. The Centre is a collaboration between the University of Aberdeen, the Net Zero Technology Initiative, and they are supported by Offshore Energies UK, Chevron Marine Scotland and Decom North Sea to ensure that the Centre's programme of work is aligned with industry requirements and priorities. So before we invite Professor Neilson to our virtual platform, I'd like to go through some housekeeping and give you a word about the Cluster Builder Initiative and CeeD. You probably all had plenty of time to read this today. We will be recording the session, and we'll make this available to those who attend the webinar after the webinar's finished. I think I've gone through this already, but please mute your speakers and switch your cameras off until the question and answer session. I think there's somebody whose microphone is open because I can hear some breathing in the background. Use the chat function to post any questions or points that you'd like to discuss, and we do hope that you will be vocal and put your questions to Professor Neilson about the work that they're doing. We may well have a break during this, the presentation and invite questions at that point. Otherwise, I'll do that at the end. I'm joined by somebody whose name I absolutely have no idea how to pronounce, but perhaps you could turn your video off for us at the moment. Is it Somashikara? Perhaps you could take your video off for us at the moment. Okay, so a little bit about CeeD. So for those that have never been to a CeeD event or worked with us, CeeD's objectives are to create a community sharing and excellence in the manufacturing sector, and by doing so, help businesses solve their operational issues that they face during, as we know, changing times. Most people who are not members of CeeD's will know CeeD for the free-to-all events like this one that we offer on a regular basis. We've run a number of events in the energy space and on sustainability in 2022, including events with the Scottish Hydrogen and Fuel Cell Association on hydrogen and aviation, some with Scottish Enterprise to showcase their grant funding for hydrogen-powered heavy goods vehicles, one organised by my colleague who's on the call, David Nicholson, with Cromarty Firth, concerning the opportunities arising in this area for the development of renewable energy, and even one on decarbonisation on the farm. The purpose of this is twofold. Firstly, to let our CeeD audience know about what's happening to reduce greenhouse gas emissions in Scotland and beyond, but secondly, to engage your curiosity in how you can get involved in these ambitions. Some people will also know CeeD for our executive education programs, including the Growth 500 and Mentoring Mix-Up initiatives. I'm not going to say anything about those at the moment, but if you do want to know more about them, please do get in touch and we'll let you know how you can get involved. But in 2020, excuse me, CeeD was also appointed as the Cluster Builder Programme Manager, excuse me, for the Advancing Manufacturing Cluster Builder Initiative. You can see the Cluster Builder depicted on the screen. This webinar is one of a number of events we've organised to let people know about the manufacturing cluster and how you can benefit from 12 projects that constitute the cluster and how CeeD can help you. The AMCB was established to create a national network of regionally based initiatives to improve the innovation performance of Scotland's SMEs, to adopt contemporary ways of working and to help businesses capitalise on new economic and public sector innovation opportunities. The network complements the support offered to SMEs by the National Manufacturing Institute for Scotland, NMIS, by providing local access to complementary support and services to ensure that SMEs, wherever they are based, are positioned to fully capitalise on advancing manufacturing opportunities presented by this national resource, irrespective of their location. The AMCB is free at source and delivered as de minimis under the de minimis funding route. So if you are a Scottish SME, ask us what it might do for you. You can see on the left-hand side of the slide the 12 AMCFs that make up the cluster. The support they offer ranges from advanced visualization techniques, such as augmented reality and virtual reality, the adoption of robots in manufacturing processes, the adoption of digital manufacturing approaches, support for renewable energy development, construction, the manufacture of medical devices, and support for early stage companies in the life and pharmaceutical sciences space. There's also an online program for anyone wishing to understand digital manufacturing, and another for those wishing to understand and be trained in traditional manufacturing techniques. So I think that's enough about CeeD and the Advancing Manufacturing Cluster, and time for Professor Neilson. My short introduction to Professor Neilson is to tell you that he's the director of the National Decommissioning Centre, and professor in the School of Engineering at the University of Aberdeen. I'm told he began his research career on the application of design and dynamic analysis to solving engineering problems, but was seconded to an oil services company from 1998 to 2002. And since then, much of his research has been in the context of oil and gas, subsea engineering and decommissioning. So thank you, Professor Neilson, for agreeing to tell us more about the centre and in particular how our audience can engage with it, and perhaps the university too. And over to you.
Thanks, Patrick. Just let me know if my screen share is okay, it'd be helpful.
I can see your screen, thank you. Is
that okay?
That's fine.
Well, thank you, Patrick. I'd just like to thank you and CeeD for the chance to talk a little bit about what we're doing. As Patrick said, my name is Richard Neilson. I'm Centre Director of National Decommissioning Centre. Originally, actually, my research was in aerospace. Started my PhD was with Rolls-Royce aircraft engines back in the dim and distant past, and then gradually moved underwater and then into decommissioning. Patrick's covered a little bit of this, but I just want to explain who we are in terms of National Decommissioning Centre, because some of you may have come across us and others may not have. So we're a partnership between the Net Zero Technology Centre, formerly what was OGTC, and the University of Aberdeen. We launched about 3 years ago, January 2019. Net Zero has put in about £12.7 million of cash, and that's from the Aberdeen City and Region Deal funding. So as with many cities, Aberdeen put in a bid to the UK and Scottish governments for a region deal a while back, and within that there was a cluster of money for what was at that time the Oil and Gas Technology Centre, now Net Zero Technology Centre, and within that pile of money was a commitment to set up 2 or more centres of excellence, one in decommissioning and one in subsea, and possibly others. And we picked up the decommissioning one. So we're partially funded by Net Zero Technology Centre, but the university is also co-investing. So the university is supplying the buildings and facilities, staff time and PhD support, which is about £6 million worth of funding. We've got an aim of matched funding from industry, so we have cash funding obviously from Net Zero, but we aim to get at least that money back and co-funded from industry for the research we're doing. And I also want to just highlight we've had some really good support from the Scottish Government's Decommissioning Challenge Fund. We've had about £4 million of infrastructure funding, which I'll try and flag up if I remember on the way through the presentation. Very good support from them indeed. As Patrick said, our ambition was to be global lead in terms of research and development that transforms decommissioning mature field management. And I say was because obviously within the last 2 or 3 years, the whole I guess narrative around oil and gas and energy has changed. So we're no longer just working in the kind of decommissioning space, we're actually moving towards the energy transition space. So decommissioning is part of that energy transition. We're obviously moving away from oil and gas and towards more renewable sources of power. But within that, there's late life and decommissioning taking place. And then obviously into the newer types of power as well. And we're kind of sitting in that space at the moment. So not just kind of hardcore decommissioning. For those of you who know the University of Aberdeen, we're a reasonable sized university, about 15,000 students, but we're not massive, so we can't do everything ourselves. So the aim was to set up a kind of cluster of linkages with port clusters, other R&D institutions, innovation centres, universities across the UK and internationally, and I'll highlight some of the partnerships we've got later. And to bring those together, along with things like the other organisations such as the UK Catapults, and to make them more than the sum of the parts, to address some of the items around decommissioning. What I would say as well is that we have an onus on us to work with companies, and that's not just not we're forced to, but we want to. But because we're part of the Aberdeen City Region Deal funding, there's an onus on us to make a difference to the supply chain and to the energy companies, both for the UK and see how things deliver for the UK and international. So the title was how we're addressing decommissioning challenges, and I just wanted to highlight some of these challenges at the moment. And hopefully I'll try to highlight as we go through the presentation where the work we're doing kind of addresses some of these challenges. So one of the biggest ones is cost reduction, and I don't know what you know about this, but 2017 was then the Oil and Gas Authority set a target of 35% cost reduction for decommissioning, and at that point the estimated cost of decommissioning the UK CS for oil and gas was about 59 billion. So we made inroads into that. It's found about 46, but there is still more cost to come out of that. And part of the reason for driving the cost down is that the oil and gas companies, the energy companies, can apply for tax reduction on the basis of the decommissioning liabilities. So effectively, of that 46 billion, a largish percentage will actually come back to the companies in terms of tax rebates. So that's money then not coming back into the treasury. So the advantage of reducing cost is, one, it reduces it for the companies, but it also reduces the burden on the taxpayer as well. And some of the questions around that, what kind of technologies do we need to use to reduce cost? And are there maybe different contracting structures we need to do? Because at the moment, everything is very competitive. So are there different ways of working which would be more collaborative and might reduce cost? The other really big topic at the moment, and these two are now almost probably equally weighted, is emissions reduction. So how do we reduce emissions during decommissioning and move towards net zero decommissioning? And again, what kind of technologies would help that, and will integration with offshore renewable power help? And so one example is that once you've got to cessation of production, you've stopped producing oil and gas, the rig or the facility then has no power of its own, and so it can't draw on the gas supply it was producing, and therefore it needs to be able to power itself up. And typically at that point, you ship out diesel generators and loads of diesel, and you run it as you plug in and abandon the wells. So the first thing you do is you plug the wells that you've been producing oil and gas from, and at that point you have no power supply, therefore you need diesel generators or some other way. And one of the potential ways of getting around this would be to start linking in offshore renewable energy. And so rather than shipping out more hydrocarbons, and other ways of decarbonising or reducing emissions by use of offshore renewables. Another really big one is kind of I've put it down as maximising environmental benefit, or you might say minimising environmental detriment. But what do we do? What's best for the environment? How do we do that? And what is best for the environment? And basically, what does the science say, and how do we communicate that to a wider stakeholder group, including governments, companies, regulators, and NGOs, many of whom have competing agendas? So at the moment, there are some suggestions that leaving some structures in place may have beneficial environmental impact in terms of fish stocks. But if you speak to the Fishermen's Federation, they would like a clean seabed and everything removed. And so there are tensions between different stakeholder groups in terms of what is best. Other challenges around commercial, and I mentioned this before, how do we promote collaboration rather than competition? How do we balance demand between decommissioning and renewables installation for supply chain services? So we have a large amount of offshore renewables going in place, and we've got decommissioning happening simultaneously, and possibly challenges between those two sectors for supply services. And another one in terms of commercial, how do we encourage the supply chain to invest in new technology? And the reason I'm asking that is because there's often a culture of major companies racing to be second, as they would say, to trial these technologies. They always want somebody else to take risk. And so the supply chain has a challenge to invest in new technologies, not being sure that somebody is actually going to pick up the trials and trial it for the first time. And then finally, we've got regulatory and how do we inform regulators of best practice and new evidence which might change regulations. And that's both UK and international. So in the UK, we have a very highly regulated system. Internationally, there are a lot of basins catching up with us, I guess, where decommissioning is further behind, and therefore they're still putting in place their regulatory structure. And quite often looking at the UK and Europe for what they should be doing. And the last one is also very important. How do we deal with the UK's liability and perpetuity law? So at the moment, if you have ever produced oil and gas in the UK CS, you can be liable for decommissioning of the infrastructure that you owned at any point. And let me just give you one example. So ConocoPhillips moved out of the UK CS and sold their assets to Chrysaor. Chrysaor are now being taken over Harbour. But if unlike the situation, if Harbour defaulted on their liabilities for decommissioning, that could be chased back to ConocoPhillips. And that means that companies have, even though they're out of the basin, may need to have money on their books for decom liabilities in case they need it. And that's a bit of a challenge. And we've actually got some PhD work happening around that. So that gives you some of the challenges around decommissioning in the UK CS. So how are we getting involved with this? We have a kind of forward plan of trying to do things smarter, safer, cleaner and cheaper. I'm not going to go through this in detail, but effectively the smarter side is using things like artificial intelligence for data sets. I've got a title here called Smart Basin. I'll come back to that in more detail later on. Safer, removal of residual hydrocarbons, big challenge before you start cutting stuff up. Robotic systems, I'll come back to a little bit as well, particularly with respect to actually nuclear decommissioning, but a big challenge around oil and gas as well. And then cleaner, in the past that would have been particularly cleaner in terms of physical cleanness for decommissioned objects, but now we're much more talking about emissions reduction. And then cheaper, I mentioned there's the £46 billion estimate for cost. Well plug-in abandonment costs about half of that, so we're looking at doing some work with a new test system which will help us to look at new ways of plug-in abandoning wells, but also looking at alternative removal techniques and post-monitoring techniques. And we've got ideas for these which we're going to move out over the next 10 years or so. What I would say is this is about to get refreshed because this does not take account of the kind of energy transition stream and renewables work that we're doing at the moment. We've got a number of partnership models. So we partner with industry and we have what we've called an anchor partnership, and I'll show you who's involved with that at the moment. But that's typically a 3 to 5 year commitment, some sort of bespoke portfolio of company-specific and/or collaborative projects. They get representation on the NDC partners group, and Patrick talked about, in fact, we've got this partner group which includes Chevron, but also some of our other partners, OEUK, DNS, Marine Scotland Science, and just recently the Nuclear Decommissioning Authority. So partners, anchor partners get representation on that and can drive the agenda of the NDC a little bit. They get space for research team within the NDC and preferential access to the facilities here. We've got a project partner model. So again, we'll work with industry, typically shorter term commitments, although it may still be long term. And one of our projects at the moment is 2 years, well now 2.5 years, so almost the same length of time. And typically company specific project or projects. And again, access to NDC facilities. And then we're very keen to work with other universities and R&D institutions, so particularly bespoke collaborative projects between partners. And Projects will normally be externally funded. We don't have a project fund pot, but we can support, we can co-fund PhDs. And again, you'll see that later on within the presentation. We can allocate space for the research team, the combined research team within the NDC, and again, we can give access to the NDC facilities. So different ways of working between kind of industry and academia and R&D centres. So I said I'd kind of flag up who we're working with. So our first anchor partner was Chevron. And interestingly, Chevron joined us just as they moved out of the North Sea. And the work we're doing with them is primarily around the environmental piece. So I mentioned about what's best for the environment as being one of the challenges. So the areas we're looking at with Chevron are around monitoring fish stocks around man-made structures. And the picture you can see here is one of the Chevron's jackets in the Gulf of Thailand. And you can see the kind of density of fish around about this. And they're really interested in what happens with this. They're going to do some reefing work, take the jacket elsewhere and use it for either commercial fisheries or recreational diving. So interested in how the fish move or what fish stocks you might be with it. The second topic is around risk assessment of mercury in the aquatic environment. So in the Gulf of Thailand and various other areas, southern North Sea as well, mercury is produced along with the hydrocarbons, and that then contaminates pipelines and process plant. And there's what we need to understand is what acceptable levels we can have. Ideally, you'd have none. You can never clean up everything perfectly. So how low can you have to get in terms of contamination before there is minimal risk to the environment? And then longevity and fate of structures left in place. I mentioned reefing, and that's one of the areas that Chevron's looking at with DMF, the regulator in Thailand, is if you reef something, how's that going to degrade, or how's your pipeline going to degrade if you leave it in place? So we've got 3 PhDs working in these areas, and they're supported by a postdoc who's currently undertaking research around habitats around pipelines, looking at biodiversity and fish stocks. I mentioned in the partner group that we've got something from Nuclear Decommissioning Authority. So as of January this year, we kind of widened out our areas of interest. And this is actually after 3 years of discussions between the oil and gas sector and the nuclear decommissioning sector, and we've partnered up with the Nuclear Decommissioning Authority to look at areas which are of mutual interest in nuclear and oil and gas sectors. And these are decommissioning cost benchmarking, so looking at the costs of decommissioning, decarbonising, so trying to reduce emissions, remote operations in hazardous environments, and that picture you can see on the right-hand side is one of the low-grade storage ponds in Sellafield. How do you manipulate things underwater within that environment safely, and potential for underwater laser cutting, and I'll come back to that later, and alternatives to cement. And that sounds like a kind of weird one, but cement is used for well plugging abandonment for oil and gas, but the nuclear sector also use it for building large structures, for example, the pool you can see here, but also use cement for immobilizing waste within their storage facilities. So a lot of interest. So these 5 common areas are what we're going to focus on over the next 3 years. And we may also have an open call for collaboration with other universities around some PhD areas, and that's still to be finalised. So this is now wider than just oil and gas decommissioning. I mentioned project partnerships, and our first major project partner was Shell. And for this case, we're looking at post-decommissioning monitoring. So if you leave anything in the sea, whether it's a pipeline or a piece of structure which you cannot remove and you're allowed to leave in place, then there's a requirement on you from the regulator, OPRED, to monitor the condition of that item. So we're working with Shell to look at the kind of what, why, when and how of long-term monitoring. So Shell have some large structures which are left in place and will gradually decay, and they're really keen to have some guidelines about what they should be doing. And ideally we want those guidelines to be accepted by the OPRED, the regulator as well, and by a lot of energy companies. So we end up with a set of guidelines which are mutually acceptable by all stakeholders. And we were just about to finish off that work, but we've been asked to do some further work around probabilistic modelling in terms of how things degrade and how that then changes or might affect the kind of monitoring structure. We've also just partnered with the Offshore Renewable Energy Catapult. I mentioned we're not just looking at oil and gas decommissioning or just decommissioning. And this was a result of the simulator work we've got going, and I'll highlight that more detail later on. So we're about to kick off 3 projects with the offshore and renewable energy catapults around marine operations for offshore floating wind, and that's primarily how these are installed, any of the other operations around about. The environmental impact of floating offshore wind, and the picture we've got there with the fishing boat is because we may well be looking at the kind of snagging risks and things like that of mooring systems for offshore floating winds. At the moment, the fishermen obviously have to take account of fixed structures for the oil and gas sector, but these are relatively sparse. But if you imagine a large floating offshore wind farm with multiple anchor points per turbine, navigating through that might be quite tricky, and knowing whether you can or cannot fish through that might be quite tricky. I think we're also going to do some work around optimization of mooring and anchor systems. And we're also in discussion, or about to have some discussions about a project around the electrification of oil and gas, one of these challenges I mentioned. So I mentioned about after you've ceased production, can you use offshore renewables? And this INTOG project would help kind of address some of that work. I mentioned laser cutting with the Nuclear Decommissioning Authority, and hope this little video will run. This is our underwater laser cutting in a tank. That blue flash you can see was the laser switching on, and that's us punching through a 26mm steel tube. So this was set up to look at how we might cut tubular members underwater. This is only in about 5 meters of water in the tank at the NDC here. So we have a 15 kilowatt laser which was supplied to, or bought through Decommissioning Challenge Fund money. This test was only run with about 4 kilowatts, but we've done tests within tank cutting steel up to 100mm thick. And we did some open water tests at Cohort last year in May, and we cut 60mm steel at 70 meters water depth. We've just applied for funding to Net Zero Technology Centre for phase 2, and also to the Innovate UK's Knowledge Transfer Partnership funding for some gas jet modelling as well. This technology kind of ticks some of the boxes in terms of reducing emissions. So we're reducing, this is lower power than some of the existing techniques, lower volume of equipment on the deck space, so less material to have to take out to a rig, and so has a definite advantage in terms of kind of carbon emissions. I mentioned well plug-in abandonment, and we're just kicking off a £2 million project funded by the Scottish Government's Decommissioning Challenge Fund to build a pressure vessel which will replicate downhole conditions. So this is going to allow us to trial new well plug-in abandonment technologies. So at the moment, wells are typically plugged by cement, but there are technologies like bismuth alloys, thermite, and resins, which people are interested in looking at as alternatives. At the moment, some of the developers have their own small test rigs. This is to provide a large-scale test rig, which will be available to the sector to test with. So we've done a FEED study, a front-end design study. We've done some cost reduction because that came in well above our budget. And we've just completed a tender and signed a contract with Sings Engineering in Ellen to supply that piece of kit. And we hope that will be commissioned about this time next year. I mentioned academic partnerships. We have a partnership with Chulalongkorn University in Thailand, and it's the second project we've run with them. This project should have finished actually, but due to COVID, we haven't been able to travel back and forward. And this is looking at sustainable dismantling of offshore structures, and it's funded by the Royal Academy of Engineering. We work very closely with Ktn University. The university's got a very strong partnership with Ktn in Australia, and we're just finishing off a 2-year project with them around naturally occurring radioactive materials and mercury, and Ktn led on the norm side of things, and we led on the mercury side of things, and that was funded by NERA, the Natural Energy Resources Australia, and through their National Decommissioning Research Initiative call. So we're just finishing that off, but also looking at how we might translate some of that work into the UKCS. We are just starting a project with University of Essex. It's a joint PhD. So it'll be a PhD funded or running at University of Essex, but co-supervised by one of our academics in Aberdeen and co-funded by the NDC. And then we're also working with University of Western Australia. We've got a joint project between UWA, Ktn and ourselves, and that's to just develop a decommissioning research roadmap for Australia. And we're providing the kind of insight from the UKCS perspective. We work with the government as well, so we've got a large project which is collaborative with the Net Zero Technology Centre, so the funding is coming through them. There's complementary projects running at the National Subsea Centre as well. And in this case, we're looking at infrastructure, reuse and repurposing, decision-making, late life and decommissioning and decarbonising. So all of these kind of tick these boxes. The decarbonising one obviously against the kind of reducing emissions, the reuse and repurposing around some of the environmental things, but also some of the cost reduction potentially longer term, and the decision-making, late life and decommissioning, particularly around cost, but also around emissions reduction as well. How we use co-action and campaign planning, how we support decisions for investment in technologies. So you can see how some of these things will tick off some of these boxes I mentioned in terms of the challenges around decommissioning. And that last one particularly is obviously the one that's very much of interest to the nuclear sector as well. I'll take a break just after this, just if there's any questions. We also run a PhD cohort, so these are internally funded, and we've got everything from financial security, I mentioned that long-term liability thing, run by Alex Kemp. We've got decommissioning bundles, complex pipeline systems, running within engineering, elimination of marine growth, which seems a kind of weird one, but actually when BP took the Miller jacket out, there was about, they estimated between 1,000 and 1,500 tons of marine growth on that. So if you can eliminate that, you're going to use a lighter lift vessel. The DNA work is looking at trying to work out biodiversity around structures by using water sampling. And in decision making and decommissioning, this will feed very much into that piece of work for the Scottish Government, looking at kind of scenario planning, impact assessment, quantification of greenhouse gas emissions. So we've got two PhDs who are just about finished, and their work will feed right back into that bigger piece of work for the Scottish Government. And we've got self-funded student working on repurposing of subsea infrastructure, and we're just about to kick off a project which will be very similar in some ways to the work we'll be doing with the ORE around snagging implications of decommissioned pipelines, and there may be some synergies between that and snagging implications of the offshore floating wind side of things. I think, Patrick, I'll maybe just take a minute break at this point, and if there's any questions, and if not, I'll carry on.
Thank you, Richard. There are a couple in the chat box at the moment. They're both from Ray, one with a potential opportunity, and the other asking you, have there been any discussions with the Infrastructure Industry Innovation Partnership, suggesting that one of the themes for major infrastructure projects is relates to net zero, and he's pointing out that the Nuclear Decommissioning Authority is a member, I presume, of the I3P partnership. So we haven't had discussions with that grouping, no. But also as we've got, yes, the NDA are driving down that route of trying to decarbonise. If you feel there's an idea in there and worth linking up, then please make that introduction. Yeah.
Happy to do that, Richard. As obviously, I've been in discussions with the NDA, and I'm aware of the cross-learning or the cross-industry learning that's going on NDA with offshore renewable energy catapults as well. So yeah, I think it's great to see that the three different sectors working closely together to share best practice and join together on projects. I mentioned I3P because, as I say, there's a number of key infrastructure projects. KTN facilitates the programme, and it's all about collaboration, getting the engineering contractors to collaborate on innovative projects that are of common interest to all the key infrastructure projects. Obviously, I said the NDA joined, but you've got HS2, Network Rail, Thames Tideway, Crossrail. And there's a couple of themes there which obviously struck a chord. One was the net zero. Yep. How can they undertake their construction activities using less, obviously, diesel assets, etc. Healthy, safe and well-being, obviously addressing that across the sector as well. And yeah, so happy to have a separate chat.
Good. Thanks.
And Ray, you asked to, or you made another comment in the chat box, which I don't think you've covered in.
Oh, right, yeah, so yeah, we also run something called the Ktn Innovation Exchange. This is where basically we talk to large organizations in the energy sector to help them address near-term technical challenges. And of late, there seems to have been quite a few net zero related challenges, decarbonisation challenges, and we've run those for the likes of the Association of British Ports. Again, very similar, that everything they do in a port, when you think about it, is from tugs to cranes to forklift trucks, is all diesel driven. What can they do? But even for British Antarctic Survey, London Fire Brigade, obviously there's a lot of organisations who have net zero challenges and targets. So we're basically using our network to provide or capture really relevant technologies, SMEs and others that can help address those solutions. So it's a competition that we run that can possibly help. So again, very happy to have a chat, see how we can support.
Yeah, definitely worth a discussion, and along with Zach from the Knowledge Exchange team. Yeah, that'd be great. Thanks.
Okay, cheers.
Thanks for that, Ray. It's been very helpful. Our audience is being shy and coy at the moment. Hopefully we can encourage some more comments. One thing from me, I was going to say to last, but I'll ask it now. Although I'll comment that I did just come back from a 2-day, it's still going on at the moment, 3-day event on aquaculture 2022, I think it's called. And I would have thought there's plenty of infrastructure in place from the offshore aquaculture sector. And that's the kind of segue into the question I was going to ask, which was, and you raised this, Richard, how do we engage the supply chain to invest in new technology? And my thought was, well, you told us a lot about grant funding and how we can use grant funding for collaborative research and to develop contemporary ideas. But you didn't outline the type of tools that you think this sector needs, and you imply the scale of such tools, but you didn't actually tell us. Now we've got some of the supply chain SMEs here. My thought was, would reaching out to actually engage the supply chain by asking them a question this sector needs help you to engage with that sector?
The answer is very much yes, and we're in the process of kind of sketching out a survey which we're hoping to send out to energy companies, regulators, and the supply chain. So I think the answer will be yes to that, and I think if CeeD could help us to propagate that across the supply chain, that'd be really good.
Yes, thanks very much. I mean, we've got Jordan on the call at the moment. Do you think that would help you if you to engage in this sector? Wasn't really sure what your interest in this particular sector is, but can I encourage you to come on and tell us a little bit? Sometimes people. Oh, is that you, Jordan?
Yeah, Patrick. Thanks for inviting me on to have a bit of a chat. Really interesting presentation, Richard. Thanks for setting out what you've set out this morning. Yeah, I think Mage's approach to this really would be the same as the approach we've really taken to all the sectors that we work in. So for a bit of background, we're a control systems design house based in East Kilbride, but we're fundamentally able to act as an R&D technology developer arm for companies who just don't have that capacity in-house. So we work with a lot of companies whose expertise lies mainly in electromechanical or strictly mechanical design, and they would look to our team of engineers, whether there's requirements for embedded sensing equipment, smart monitoring, real-time monitoring, data feedback wirelessly over 4G or Bluetooth, and things like that. So we're working quite a lot, predominantly in the aerospace sector, but a lot of our expertise does come from aerospace and defence, and we're able to leverage that right across oil and gas, renewables, energy. So we'd really be interested, Richard, in seeing where the real pain points for your organisation, and how could an SME like Mage help to ease some of those pain points?
Okay.
Yes, thanks for that, Jordan. That's helpful. No other questions that I can see at the moment. I've made a couple of comments, but we can save them until last. But I know we've got Harriet Watt on the call, and I know that we've got Napier on the call. And if we're talking about academic engagement,
yep,
it'd be great to hear more from some of the students about their interests, and also great for some of the other SMEs and their involvement. But pass back to you to continue the presentation. Thank you, everybody.
Thanks, Patrick. Okay, and so just so you're aware, we're not based in Aberdeen Centre. We're actually up in Newborough, about 10 miles north of Aberdeen, and we're based in the two buildings you can see here. I will apologise to any of you who notes that we've got the wrong. This is an old photograph with the Net Zero Technology Centre's previous logo, so my apologies to them. The buildings are built for deep water marine exploration a number of years ago, so we've actually got some really good test facilities. We've got hyperbaric testing down to 7,000 metres water depth. We've got a 5-metre deep immersion tank, which was used for the laser cutting tests before we went offshore. We've got environmental testing from about -40 up to 150 degrees C. We've got our laser, which is one of the biggest in university hands. We don't have a supercomputer that looks as cool as this, but we upgraded the university's hypercomputing cluster last year, so we've got about 500 cores and half a petabyte of storage available to us, and we've got some workshop facilities. Biggest investment to date, though, from the DCF and ACRD funding has been our simulator. So we have in the building I'm sitting in at the moment, we have a 9-metre diameter immersive environment. So we've got, let me just go back for a second. We've got 4 control chairs, you can see on the left-hand picture there. Our setup's flipped around the other way. Our right-hand chairs are crane and ROV controls, and our left-hand ones are vessel controls. But we've got 300-degree immersive environment, 4 control stations. We can control ROVs, cranes, personnel, vessels, or new technologies. It's all real-time, real physics. We can create and modify simulations in runtime. I'll give an example of that. We can split the screen up into 4 separate sections, and we've got all objects within the scene have full effect from the environment, wind, wave, current, so on. We've got a large library of vessels, ROVs, cranes and things, but we can also import stuff to the simulator. There are 2 aspects of simulator. One is marine simulation, and that's scenario planning for decommissioning or trialing new technologies, and I'll show you a couple of examples. But we've also got what we call smart cities capability, which is the ability to visualize, analyze and model data rather than mechanical systems. And OSC, who supplied our simulator, is the preferred platform for the UN Smart Cities program. We're not just tied to oil and gas, as I mentioned. We can look at offshore floating wind or decision making or energy integration. So this gives you a view of the inside of the dome. So this is looking into the system with the 4 chairs, the control chairs. You can see the screen split up into 4 parts. A little bit of another view of the inside the dome there with a view of one of the models we've got created, which is one of Aberdeen's South Harbour. So each person gets their own view, whether it's a ship or crane or personnel or ROV. And this is a little video of a technology by Ecos IP, now MWNW Consulting. So this was a buoyancy system used to cut conductors underneath a jacket. The orange tubes you can see on the ROV take the buoyancy or provide buoyancy to lift the weight of the tube. We can then drive away from the jackets with the ROV. So the ROV is not only producing thrust, it's not going to produce lift. Take that to a basket and then recover back to the surface. So this is an operation that would be really quite hard to do otherwise. This is speeded up. This would be quite difficult to do otherwise, and this has never been done before. So this is us trialing in real-time, real physics within the simulator, an operation which has never been undertaken in real life. And just to give you an example of how quickly we can modify things, this is speeded up. This is probably 10, 15 times speeded up, but this is bringing a vessel into the new port in Aberdeen. It's actually on the wrong side of the harbour, should be on the inside of the harbour, but we can winch the vessels in. We can go to the library and pull in a column very quickly. We can go to the library and pull in a crane. We can then drive that crane either from the control chairs or from one of the computers, connect up, and then do the lift ashore. So this is probably 15 or 20 minutes work in real life, but it does show that you can decide what you're going to do and change things within the simulation in runtime. You're not set up and then run the simulation and then have to go back and modify it. You can modify it while you're running. I mentioned that we're doing some work around offshore floating wind. We're working with the Floating Offshore Wind Centre of Excellence and Aubin to look at a new type of anchor installation for offshore floating wind. And the idea of this is to get away from having to use heavy lift vessels. So the idea of this is to float out the anchor and then use some of Aubin's heavy fluids to ballast that down and have it in place. So we're doing virtual sea trials of these with different wave conditions, different wind, hydrodynamic loadings, and so on. And the little video clip here you can see is of this, the vessel having towed out the anchor. We then ballast down a little bit. So anchor weighs about 160 tons normally, can be loaded off into the water on shore. And the graph you've got in the centre here, try and do this without changing slide. This is it dropping down under the stern of the vessel, then we lower the winch down to seabed. Depending on the speed of the winch, we get a variety of positions and we can check how accurately we're going to move. But we can also do things like monitor. In the top graph here is the load in the winch. And in this case, it's not particularly good because we've got spikes, and that's because the wave motion of the vessel at the bottom here results in a kind of start-stop motion of the anchor. So the idea is to kind of optimize this, and so we end up with as light a winch as possible, smaller vessel as possible, to deploy these systems. I mentioned smart cities. Smart cities concept is that we gather data by instrumentation of other sources. We visualize that data in terms of spatial distribution, it might be CO2 emissions or airborne particles. We try to model how systems interact and change the data. So how, if it's a city, how changes in traffic flow affect emissions or particulates, and then we make some decisions around that. And what we're trying to do, partly in the Scottish Government's funded project, is to build what we call Smart Basin. So in this case, we will create a virtual model of the entire basin, starting with east of Shetland, as it turns out at the moment. We'll visualize some of the data, and that might be CO2 emissions, power usage, vessel traffic, available local renewable capacity. Try to understand how these systems interact, whether it's campaigns or use of renewables to improve efficiency decommissioning, and then make better decisions on a basin-wide basis. And we're very keen that we include all stakeholders in this, so not just the oil and gas sector, but also the renewables sector, whether it's floating offshore wind, fixed wind, marine turbines, and also the fishing sector, because obviously there are key stakeholders amongst this as well. When we got the system built, this kind of virtual walkthrough of the simulator, to kind of highlight this, we've actually got a model of Aberdeen built, and the idea for that is we're going to do some work with Aberdeen Harbour Board. You can just see the harbour, the partly built harbour going off the corner there, around, and Aberdeen City around the new harbour and possible traffic routes for that. This is some work by OSC in Bergen, so it gives you an idea of the kind of scale of areas you can cover, and we can put all sorts of data on top. With the red and blue bar graphs here, can mimic any kind of data we want. Or in this case as well, the kind of lollipop you can see sitting up here is actually the strategic development goals for the UN and how Bergen maps onto that. Not tied to oil and gas. I mean, we can put a wind farm in and put in emissions data, or sorry, I shouldn't say emissions data, but power data, and label these up and then see how things change. So this project is just starting. We're going to kick this off with the Net Zero Technology Centre, and we've got a partial build of the East of Shetland cluster at the moment. Around that project, I mean, some things we're looking at, particularly decarbonising decommissioning. So our aim with that was to reduce decommissioning emissions, and so first thing being to kind of examine the decommissioning objectives, processes, develop emissions reductions measures, whether those are reducing the scope or change the technology, and then kind of model and optimize decommissioning. And then we'll hopefully inform stakeholders of how we might do that, and then support supply chain and decision making. And the ask for industry for this sort of large cluster of projects primarily is around data. So we're looking for asset related data, spatial, structural, operational emissions, any process or procedural insights around decommissioning or late life action. But also we might do some bespoke scenario planning, in which case we'll be looking for funding for that. So I'll provide these slides to Patrick. I realise time's going on quite quickly at the moment, and if you're a company you're interested in this, then please get in contact with us. Patrick asked us to kind of highlight how we work with people. So if we work with industry, the first thing is please contact us, and you'll find our website, and I'll send an email out with that as well. Typically how we'd work then, we try to identify the need or challenge you've got and the expertise within the NDC or its partners. So if we don't have the expertise here or within the University of Aberdeen, we would go try and find out who to partner with. We'd have a decision as to whether this looks like an anchor partnership, whether it's a long-term project or it's a project partnership. And then we'd formulate that project with work packages, deliverables, resources, and those resources might be research staff, it might be PhDs, but they may not be suitable, and use of NDC facilities and so on. I think one of the key things obviously is to identify potential source of funding. Now that may just be core funded by the company, but it may be we can leverage other sources of funding, for example, a joint bid to the Net Zero Technology Centre or use of knowledge transfer partnerships, Innovate UK funding and things like that. And then obviously we try and secure that funding and then initiate the project. In terms of working with universities, again, I guess we want to identify the research challenge to be addressed and the complementary experience within the NDC and the partner organisation. Obviously, we don't want to replicate things. We would like to work with companies, organisations where we bring something to the table and they do, and we work out a very good package of work which uses the complementary skills. And again, we do the same thing: formulation of project, work packages, deliverables, and again, identification of funding sources. And that will depend on TRL level, technology readiness level. So if we look at fundamental research, it might be UKRI, Engineering and Physical Sciences Research Council or Merck. But if it's medium kind of TRL, it might be co-funded by industry, it might be NZTC, it could be transfer partnerships or Innovate UK, and then again, secure that funding and then initiate the project. So just in summary, we kind of aim to do state-of-the-art decommissioning research across the life cycle, but wider than that now also into the kind of energy transition side of things. We are industry-led. You can see the companies we're working with. I haven't flagged all of them, but industry-led, collaborative and innovative. Very much interdisciplinary. We've got colleagues from biological sciences, law, economics, and engineering, chemistry, computing sciences involved at the moment. So quite a wide interdisciplinary group, and that interdisciplinary work will be even more important for the work that we're doing with the Scottish Government around decision making, emissions reduction and reuse and repurposing. We have some state-of-the-art facilities, the simulator, laser high-power computing cluster, and we're trying to build a critical mass of expertise both within our staff around here, but also the students and our researchers. And where we don't have the capacity to do something, or we don't have facilities, we'll do signposting the best facilities for specialist requirements. So I'll leave it at that, and hopefully it's been a useful presentation. Back to you,
Thank you. Thank you, Richard. I certainly found it fascinating. I hope everybody on the call that did.